this. All right. So I'll just go over all of these if you want me to. All right. So number 1A. And so the rest of you, you realize this is being recorded, okay? I just want to make sure you guys know that. Okay, so what you need to remember is anytime you have a hydrocarbon.
Screen, please.
Sorry? Oh, wait,
Please.
we're not in a screen share?
No.
Okay. Now we are. There we go. How's that?
Yes, thank you.
We'll get there. Technology, man, technology. All right. So anytime you have anything that's a compound that's a CXHY, burning means combining with oxygen. When you burn these, you get carbon dioxide and water. And so this is what you have to remember. Whoops.
Burning means combining with oxygen?
Yes. Yeah, anytime burns means plus O2. But the only thing you pretty much have to remember, the only thing that you're going to burn in this class are hydrocarbons. And so then to balance this one, C6H14, and then I forget who it was, asked me what order should we balance in. So always do hydrogen and oxygen. Yeah, so this is a good example of that. It's just because you can see oxygen's in almost every compound. And so when we count, we have 6 carbons, 14 hydrogens, and 2 oxygens on this side. On this side, we have 1, 2, and 3, because 2 oxygens here and 1 there. So to fix this 6, we need to put a 6 in front of the CO2. Anytime you change a coefficient, you should do your count again. So that means that there are now 6 carbons. The hydrogen didn't change, but there are now 12, and 1 is now there's 13 oxygens. Again, we're not going to balance it till we get there, but you want to keep track of what you've done. So now the carbon's balanced. So the hydrogen is now 14 on the left, 2 on the right. So to fix that, we want to put a 7 in front of the water. That doesn't change the carbon. The hydrogen is 14, and now the oxygen is 12, and 7 is 19. All right, so now to fix the oxygen, we need to put something here that's going to make it to 19. And so this is one of those where you can use a fraction. So let me just move this over just a little bit. So if we put a 19 halves here, 2 times 19 halves is 19. So now it's balanced. And we don't like fractions in balanced chemical equations, but it is balanced. But we can multiply all of these by any number we want as long as we multiply them all by the same number, and it'll stay balanced. So if we multiplied each of these by 106, it would stay balanced. But we're just going to multiply by that denominator to make the 2 go away. So we multiply everything by 2. And so then you'll get 2 C6H14, 19 oxygens. Then you have 2 times 6 is 12 CO2s, and then 2 times 7 is 14 waters. All right, so that's A. I'm going to leave that up while I do B. If you guys have questions about anything I just did, now would be a good time. All right, so let's look at B. Yeah.
Whenever you have a diatomic ion, you would include a 2 at the end, because like you have hydrogen and on the product side.
Yeah.
And you have a 2. So anytime you would have a diatomic ion, you would put a 2 next to it as a subscript?
Yeah, you don't want to say things like that. No, not necessarily. No, you just have to put whatever coefficient in front of it to make it balance.
Okay.
So whatever's going to work. So there's no rule like if there's a diatomic, there's going to be a 2. Diatomic means that there's a 2 subscript, but it doesn't have anything to do with the coefficient that's going to be in front of it.
Okay, that's what I meant, the subscript.
Oh yeah, diatomic means 2 atoms. So the diatomic elements, just to help you remember those, the diatomics, the ones that are always a 2 if they're not combined with something else, are H2, O2, N2, and then the halogens, fluorine, chlorine, bromine, and iodine. Okay, so it can have a different subscript if it's combined with something else, but when it's by itself, it's always a 2.
Okay, thank you.
All right, so 1B, and that's something you should know for the test as well. 1B says zinc reacts with phosphoric acid. So you're going to have zinc. Phosphoric acid means the ion was phosphate. So that's PO4. All right, and PO4, remember, is a -3, so we need 3 hydrogens. So that, again, you have to have some pattern recognition. This is a single replacement. So this is A plus BX makes AX plus B. And in this case, we're just going to assume that this reacts because the way the question is written, complete and balance it. So the zinc is going to replace the hydrogen. Now, zinc forms a +2. So it's going to be ZN3, PO4, 2. And then getting to that, your last question, it's going to knock the hydrogen off, and the hydrogen will be a 2. And you do have to kind of recognize patterns. Okay, I see when you have an element with a compound, right? ABX, an element with kind of an ionic compound is going to do that. And again, the reason this is a 3 and a 2, zinc forms a +2 ion, phosphate from your polyatomic ion list is a -3. All right, so then to balance these, I would do the zinc, it doesn't matter until you get to hydrogen and oxygen. Do hydrogen and oxygen last. Like that. And so then we count. We have 1 zinc, 1 phosphorus, 3 hydrogens, and 4 oxygens. On this side, we have 3, 2, 2, and 8. Looks bad, right? So now we'll just try to fix the zinc. So I'm going to put a 3 in front of the zinc. That takes care of the zinc. The zinc is fixed, right? Now we'll go to the phosphorus. So the phosphorus, there's 1 here, there's 2 here. So I'm going to put a 2 here. That makes the phosphorus a 2. It doesn't change the zinc. It makes the hydrogen a 6. And it makes the oxygen an 8. Right? So now we'll go back over here. The zinc is balanced. Phosphorus is balanced. The hydrogen is a 6 and a 2. So we'll put a 3 here. That makes that a 6. And everything else fell out for us. All right. Questions about this one?
No.
All right.
Thank you.
I'm going to keep going since you asked me to just go through these. Remember, the answer key to these is posted as well. But me explaining it is more than the answer key. But if you want to look at it later, it's there. All right, let me do, I'll just keep going since that's what you asked me to do. 2A, so these we're going to balance. We're going to do ionic equations. So let me pull up. Now you need to have this memorized. But I'm going to pull up hydrochloric acid and magnesium hydroxide. I'm going to pull up a couple of files here. So that they'll take a minute to upload, but that's all right. Let me find where they are. Pull up the solubility rules. The solubility rules, remember, will be attached to the test. And that'll come up. But I'm going to just show you how to use them. So like I said, this will be attached to the exam. And then, but this flow chart will not be attached to the exam. So you definitely need to know how to use this flow chart. All right. So let's see if I can get these things in the right spaces here. We're just going to have to go between them. All right, so the first thing we need to do is write the balanced equation. So this is the nomenclature piece. So hydrochloric acid is, so hydro means it's a binary acid. That means it's going to be H. And hydrochloric means it's chlorine, so it's HCl. Magnesium is a +2. Hydroxide is one of your polyatomic ions. It's a -1. The products, actually, let me do this. Let me just move this down just a step. I'm going to do it this way. I'm going to put in every step. So magnesium hydroxide, the products will be where these switch. So the H plus will go with the OH, and the Mg 2 plus will go with the Cl. If you take the extra minute to do this step, it's much harder to make some of the mistakes that people make very commonly, like putting the wrong things together. You don't want to put the H and the Mg together. But if you don't write the charges, it's not quite as obvious. All right, then the products HOH, you can write it like that, but it's helpful to realize it's H2O. And then I'm not going to go through the balancing steps because I think you guys can do those, but you need a 2 here and a 2 here to balance it. All right, now, this is where we use the flow chart, is we need to determine the types of substances. So first thing we'll do, if you look at the flow chart, the types of substances are ionic, covalent, or acids. All right, so this is an acid. This is ionic. This is covalent. And this is ionic. Ionics always contain a metal or a polyatomic ion. Covalents are two nonmetals. Acids are going to begin with H. So then for the acid, we need to know if it's strong or weak. The strong acids are in this box right here. So this is a strong acid. For the ionic compounds, the two ionic, we need to know if they're soluble or not. So to use the solubility rules, just go rule one at a time. So this is not a nitrate or an acetate. It doesn't have an alkali metal. It doesn't have a halogen. It's not a sulfate. So this is going to be, it's a hydroxide. And hydroxides are insoluble except barium and calcium. So this is insoluble. Then for the magnesium chloride, not a nitrate or an acetate, doesn't have an alkali metal. Remember, alkali metals are group 1. It has a chloride, and they're soluble except with silver, lead, and mercury. That's magnesium. That means this is soluble. All right, so now that takes care of the solubility rules. So now what do we do with them? Soluble ionics, we break into ions. All right, strong acid, we break into ions. So this is going to be, I'm going to squeeze it in down here. 2H plus, 2 chlorides. Insoluble, we leave unchanged. So we just leave it alone. Covalent, we leave unchanged. So 2H2O. And then the soluble ionic, we break into ions. Like that. And then we're going to cancel out the spectators. So I'm just going to squeeze it over here just to clean it up. So the net in this case is 2H plus Mg OH2 goes to 2H2O plus Mg 2 plus. Let's do the next one. So what you really want to have memorized for ionic equations is the process. Obviously, the nomenclature is very important, writing balanced equation. But if you just know the process, which is pretty much this flow chart, then you'll be good because the other tools you'll have available. All right, what was B? Ammonium phosphate and iron 3 acetate. All right, so 2B is ammonium. think I could remember something for 10 seconds, right? All right, so then same approach, write down what the ions are. Yeah, as you get better at this, you more practice, somewhere along the line, you can do some of this in your head. But while you're learning it, everything you write down is one less thing you have to remember. All right, so the products are going to be NH4 plus, acetate ion, and then the iron with the phosphate. All right, so then to put these together, this will be NH4, 3PO4, Fe, so 3 plus, so C2H3O2 3 times, NH4C2H3O2, and FePO4. All right, so there's your, and then to balance it, we're going to need a 3 right here. All right, so now what we need to do, let's go back to that flow chart, wherever it went. Here it is. All right, so we have to determine if they're ionic, covalent, or acids. All of these are ionic because they all contain a polyatomic ion or a metal. So these are all ionic. So if they're ionic, we just need to look at their solubilities. All right, so for the ammonium phosphate, the ammonium phosphate, it's not a nitrate or an acetate, but it has an ammonium. That means it's soluble. So this is going to be soluble. For the iron 3 acetate, it's an acetate. Acetates are soluble. Ammonium acetate is soluble because it's an ammonium and then the last one is the iron 3 phosphate. So it does rule 1, rule 2, rule 3, rule 4, some of those, it's a phosphate. Phosphates are insoluble. All right, so then from the flow chart, soluble ionics, we break into ions, insoluble, we leave unchanged. So this is going to be 3 NH4, whoops. Let's try that again. 3 NH4 plus a phosphate, Fe3 plus, 3 acetates, soluble ionic, 3 NH4s. And see, if you listed the ions up here, it makes this part much easier because you've got them right in front of you. You don't have to remember what the ions are. And then the insoluble, we leave it by itself. And so then we start canceling spectators, the acetate. So our net is PO4, 3 minus, Fe3 plus, FePO4. Let's do these. Whoops. I'll rewrite that part that I just erased accidentally. That was okay, so now to C, what was C? Sodium sulfite and hydrofluoric acid. Hydrofluoric acid is a nasty acid, but it's a weak acid. If you've ever been like at a street fair and you see somebody like have a white, colorless liquid and they have like a paintbrush and they take the paintbrush with the liquid and they write on glass with it and then it etches the glass. That's hydrofluoric acid, etches glass. There's your fun fact for the day. All right, so sodium sulfite. Sodium is Na+. Sulfite is SO3, 2 minus. Sulfite, right? Remember 8 is the one you have to memorize. The I you can figure out. Hydrofluoric, that means it's just H and F. Whoops, F minus. So the products are going to be Na+ and F minus, and then H+ and SO3, 2 minus. So when we put these together, Na2SO3, HF, NaF, and then H2SO3. Now, H2SO3 is one of those 4 decompositions. So you need to remember there's only 4 that you have to memorize. There's actually a lot more, but there's 4 that are common. That's going to decompose into H2O and SO2. And you just have to keep an eye out. They're H2SO3, whether they're in the background for experiment 8, they're in one of the slides. I don't want to write them down here. I can in a minute if you want me to. All right, so then to balance this, we're going to need 2 here and 2 here. So just kind of cross that out. So then we go through the types of substances, which is on that flow chart. So ionic, covalent, or acid. Okay, anything with a metal is going to be ionic. This is, of course, an acid. This is ionic. This is in toothpaste, sodium fluoride. And then these 2 are covalent. And so then for the ionics, we need to determine if they're soluble. So we go to the solubility rules. And so this is a sodium compound. All compounds containing alkali metals are soluble. Right, sometimes people will go down here and they'll see this with a sodium. That's why if you go in order, you won't worry about things like that. All right, and then the acid, the only thing we have left, is it strong or weak? Well, stronger in this box. HF is not in that box. That means it's a weak acid. And then covalence we don't have to worry about. Okay, so then we do soluble ionics. We break into ions. So 2 Na+, SO3, 2 minus, 2 HF, 2 NaF, I'm sorry, 2 Na+, my bad, 2 F minus. Because we break this into ions as a weak acid, we leave it alone. And then H2O and CO2, I'm sorry, SO2. Right, covalent, we leave alone. And then we're going to cross out the spectators. In this case, the only spectator is the sodium. And so our net ionic equation is a sulfite ion plus 2 hydrofluoric acids will give us 2 fluoride ions, water, and sulfur dioxide. All right, so there's your ionic equation. You guys have any questions about 1 and 2?
Yeah, so how the decombustion reactions just occur like within the reaction, is it the same for combustion? Like it can just be within a reaction?
I mean the decompositions.
Okay, so only the decompositions happen like within a reaction.
Yes, and what you're looking for is, does the product decompose? And as long as since you asked about those, I will give you the other 3. So anytime you see any of these compounds as a product, and experiment 8 actually really helps with the lecture in this case. So if experiment 8, I think is being turned in this week in all the labs. So that, you know, if you've gone through that, that really helped you with the lecture as well. Because the ionic equations piece is all over that. Yeah, so if you see any of these 4 substances as a product, like here, just immediately break them down to this.
Okay.
All right, any others? Well, I'm going to erase the board here. I'm going to close, we don't need this open anymore. And we don't need this open anymore.
I actually have a question.
Okay, go ahead.
Just, it's regarding the 2B, if I wanted to put in like the states of matter,
Okay,
for the iron 3, what is it? Iron 3 acetate, that's the aqueous. When I write the net ionic at the end, would it go back to being a solid?
the only thing that's a solid, so for state labels,
Yeah, for like in the net ionic.
aqueous
Yeah.
will be soluble ionics, acids, and then uncombined ions. So all of the ions would be aqueous.
Oh, well.
Solids are going to be insoluble substances. So this would be a solid. Liquid, in Chem 152, water. That's the only one. And then gases are going to be most covalent compounds.
Oh, wow.
That'll help you a lot. So water's a liquid, SO2, CO2, NH3, H2S. These are all going to be gaseous. Any soluble ionic or any acid will be aqueous. The ions by themselves will be aqueous. I don't, my colleagues require these a lot more than I do. In Chem 200, they're definitely going to want you to put those on there. I strongly encourage it, but I don't require it, just because I think you guys got enough to worry about. But you know, in Chem 200, they expect it. So.
All right, thank you.
Anything else before I erase this? All right. Tell you what I'll do. I'll just erase the top one, just to be on the safe side. Kind of do it like that. Whoops.
Thank you so much, Professor. I really appreciate it.
Oh, sure. That's what this is. That's what this time is for. If I
Thank you.
didn't want to do this, I would not make this time available. And like I said, I'll when this is done, I'll post it in the I'll post the video, the recording in the welcome and helpful information. It'll be at the bottom.
That would be awesome. Thank you.
It'll be late morning, early afternoon. It's just gonna be a function of me getting to it, and it kind of depends on how busy I get. But when my lab is over for sure, that's when I'll do it then. So that, but it will be available. I only record them if someone asks me to. I don't do it by default. All right. I know some people just record everything, but I kind of figure if you ask me, I'm more than happy to. All right. So number 3, I'm not going to write the question. It says, what mass of calcium phosphate will be formed from the reaction of this many phosphoric acid molecules with excess calcium chloride? So what you need to be able to do with this is write it. Obviously, there's a balanced chemical equation because it says reaction of. So one of the things students have a lot of trouble with is just going from here to the equation. So calcium phosphate be formed from, that means calcium phosphate is a product. Okay, reaction of phosphoric acid with calcium chloride. So we have, those are the reactants. So I'm not going to go through the nomenclature piece here. On the test, of course, if you look at the old test, there's some flat out just here to name these compounds. I didn't put that on the review because you kind of have to do that in the review, but you definitely are. I'm going to give you some like that. If you look at the old test, the structure is going to be similar. The only thing is the old test, of course, I don't have it in a Canvas form, but those are the questions. They were in Canvas. I just don't post them that way because it's hard to post them. So calcium phosphate, phosphoric acid is reacting with calcium chloride. The product is calcium phosphate. Now you're not told in this case what the other product is, but you need the other product in order to balance the equation. The other product is going to be the H with the Cl. Now, if you feel like you want to go through this process down here to get the equation, then you should definitely do that. right? But this is the balance. This is the unbalanced equation. To balance this, we're going to need a 2 here, a 3 here, and a 6 here, right? Then you're told you have 3.35 times 10 to the 21. Molecules, and you want to find grams. Right? So doing that really helps to set it up. Make this a little bit wider. Oops. All right. So we always want to go towards, the question mark here, so to speak. So we know the answer is going to be in grams of calcium phosphate. It's really helpful to always write the units of the answer right away. I've seen people do problems like this and they solve for the HCl or this, and they did it right, but that's not what you were asked. It would be like if someone said, how much does it cost to buy a car? And you said Wednesday. Completely unrelated answer. All right, so now we're obviously going to start here. If you want to map it out, we're going to get on the mole highway there, take the mole highway to there, and then we're going to get off the mole highway. All right, so then we're going to use, so we have to get to moles. Okay, to get to moles from molecules, we're going to use Avogadro's number. So we have 1 mole of H3PO4 for Avogadro's number. All right. Now we have to get to calcium phosphate. So we're going to need to get to moles of calcium phosphate before we can get to grams. We can always get to grams from the molar mass, and you could even put in that step. The molar mass of calcium phosphate is 310.18. So if you weren't sure what the next step is, you could always work backwards a little bit. I have to get grams here. We always know, if you know what the compound is, you know the molar mass. So now that means all we need is moles of calcium phosphate in the top. And moles of phosphoric acid in the bottom. We know that because we want to cancel this and we want to cancel that. And so we know that there are 2 moles of phosphoric acid for 1 mole of calcium phosphate from the balance equation. Make sure the units work. And then we reach for our trusty dusty calculator. So that's point, and then don't forget about sig fig, so 0.863. Right, that's number 3. Questions about that one? And remember on the test, right, you're going to have that, have some scratch paper. A question like this is just going to be, put in Canvas, it's going to be put the answer in. But obviously there's work, and I'm pretty picky. If there's no work at all, you're going to get a 0, even if your answer is right. But more importantly, you want the work, because if you skip this step accidentally, you'd still get 8 out of 10 if you show it to me, because it's like, all right, you knew what to do, you just forgot one step. But if you don't do that, I can't give you anything. So definitely want to show your work. All right, and I've been doing this stuff for a long time. I can't do this in my head. All right, number 4. Okay, number 4, I apologize for this on this key. I didn't realize that we deleted oxalate from the polyatomic ion list. So there won't be any, if you have oxalic acid on the test, I will give you the formula. Because we used to require students to know that ion, but the polyatomic ion list that you have was generated years ago. I went to the Chem 200 instructors and said, what do you want them to know? Because this is a prep course. And every so many years, I kind of go back and they go, yeah, don't make them memorize oxalate. but I've been using this same set of practice problems for a minute. So anyway, so this is oxalic acid and sodium hydroxide. So we have NaOH. Oxalic acid comes from oxalate. Oxalic acid is found in rhubarb leaves. That's why you don't eat the leaves, you only eat the stems. The products will be Na2. For those of you who are biologically inclined, if you know the Krebs cycle, the tricarboxylic acid cycle, first step is oxaloacetate, derived from that. There's your fun fact for the day, or your second fun fact. See what you get, all sorts of useless information. Balance, so we get a 2 and a 2. Then you're told we want to find molecules from grams. So we have 0.1558 grams. We want to find question mark molecules. Okay, and so that means our answer is going to be NaOH molecules. So we're always going towards the question mark. So we're going to get to moles here, like that. So we have 0.1558. I need a sip of coffee. Grams of oxalic acid. Right? And then we want to get to moles. So we need them. So to go to moles from grams, we use the molar mass. Molar mass of that stuff is 90.035. That's a 90. All right. There, so you can see it. Then we have to get to moles of sodium hydroxide. There are, because we want to get to sodium hydroxide. So there are 2 moles of NaOH for every mole of oxalic acid. I always cancel as I go. All right, and it's a good idea, a good habit to get into. Don't just write moles, but moles of what? Because otherwise you don't realize that these aren't the same. And then we're going to go from moles to molecules. So we use Avogadro's number. All right, make sure your units work. And so I get 2.084 times 10 to the 21st. All right. Questions about this one? There's one more. All right, calcium chloride formed from, right? And by the way, getting back to number 4, words like neutralize, that just means reacts with. I try to put in different words to get you guys used to seeing different ways these are written, so that, as you progress, because you can do a lot more of this in Chem 200, right? And really important, if you have a good approach to problem solving, once you get good at the dimensional analysis, once you get, learn how to really set up problems, then it almost doesn't matter what the problem is, and makes it a lot easier. All right, what mass of calcium chloride will be formed from calcium hydroxide with hydrochloric acid? All right, so this is number 5. So we have calcium hydroxide reacting with hydrochloric acid. What's it asking? It's asking calcium chloride. Again, you need the other product to balance it. It's going to be HOH or H2O. And again, if you want to write water as HOH, you're an organic chemist if you do that. But there's nothing wrong with doing it that way. All right, so now we just want to have the information. So this is 1.37 grams. Calcium hydroxide is 1.638 grams. And we want to find question mark grams. I'm going to erase all this down here, so I need all this space. All right, so now this one's a little different because see, if we're going to look at this, we go, well, how do we get to here? Where do we start? And so this screams, this is a limiting reactant problem. So the signature of a limiting reactant problem is when you have two starting materials, not supposed to be a one. So you don't know which one to start with. So that means we have to figure out the limiting reactant here. So there's a lot of different ways to do this. I know I showed you two. If you've seen another way that you like it better, then do it that way. But the way I do it is we have to, first thing we need is to get to moles of each thing. So we have 1.638 grams of the calcium hydroxide. And we have 1.37 grams of HCl. We need the molar mass of these. So the calcium hydroxide is 74. Whoops, OH2. I'll just do the math here. So this is 0.02211. Moles calcium hydroxide. And then similarly for the HCl, 35.453 plus. So this is 36.461. So this is 0.0376. So we have the number of moles of each thing. Then what we do is we have to figure out which is the limiting reactant. And so what we're going to do is arbitrarily choose one and figure out how much of the other we need. So I'm just going to choose the calcium hydroxide. And from the balanced equation, I know that I need 2 moles of HCl for every mole of calcium hydroxide. I set it up like this. And you don't have to use my organizational scheme, but when you're doing problem solving, it's good to be organized. So instead of scribbling things all over the place, be organized. A little bit for the partial credit, but more importantly for you, right? Just have some type of organizational approach. All right. So if I'm going to use up all of the calcium hydroxide, I'm going to need this many moles of HCl. I don't have that many moles of HCl, so I'm going to compare what I have to what I need. Since I have less than I need, that means this is my limiting reactant. If I had more than I needed, then the calcium hydroxide would be limiting. Since there's only 2 reactants, you really only have to check one of them. All right, so now that we know the limiting reactant, we can answer the question. Limiting reactant, and we may as well start with moles. Since the first step is calculate moles, I already did that. And we want to get to, the final answer is grams of calcium chloride. All right, I know from the balanced equation that I have 1 mole of calcium chloride for 2 moles of HCl. And then I think this is 110.99. Yeah, then I use the molar mass. All right, divided by 2 times 0.0376 is 2.09. And you want only 3 sig figs. All right, questions about this one? All right.
Professor, according to the sig fig,
Yeah,
so for example, at the first of this problem, there is 3 sig fig. So at the end, we have to give you 3 sig fig. Am I right?
that's right.
Oh, okay. So the others number, it doesn't matter, even there is lower sig fig.
What other number?
Like for I mean, for example, compound mass of like one, reaction. For example, it was like,
Oh, the coefficient in a reaction?
yeah,
You mean like the 2 here?
like, yeah,
there?
2, yes, like 2 here.
So remember, sig figs are only numbers that are measured or things like that. So a number that's like balancing an equation, that's a pure number. So
No.
that's like a counting number.
I mean, the compound, for example, the compound molar mass of H2 is, I think it's 0.1.
Oh, so molar masses, you should carry them 1 more digit than you're going to need. You can carry them out pretty far. I think most periodic tables give you 2 decimal places.
Uh-huh.
So carry molar masses to at least 2 decimal places. But see how, for example, see this one here, the calcium hydroxide had 4 sig figs. I carried the molar mass to 5.
Uh-huh.
That I don't want to call it just 74 because that could cause a rounding error. Probably wouldn't, because it's, but it's a good idea. Your molar mass does not determine your sig figs.
Oh, okay.
Right. The only
Thank
numbers you're given in the problem.
Okay, thank you.
Any other questions before I'm going to stop the share and I'm going to stop the recording?
Mm-hmm.
But I want to
No.
make sure I'm done before I do that.
No, I'm okay. Thank you.
All right. I'm going to stop the recording. Like I said, I'll post this. How do I stop recording? Stop recording. There it is. Okay, it takes Canvas a while.